The following is an example, again, how you can leverage Excel functions. In this pivot table, we have accounts. As we rifle through the dimensions, we have products, we have the company itself, and a data type. And we're going to actually showcase the rank function here. So let's first explain how the rank function works. We're just going to put in some sample data here from 1 to 900 for product 1 to 9, and then to put the function in. I want to rank the number to the left here, my data element, as it relates to all the data for product 1 through product 9. I anchor that, and then I return, and it ranks 9th. If I take that and I run it across the values, you can see, and as you can see, product 1 is ranked the lowest and product 9 is ranked the highest. So how is that concept leveraged in Rumfox? We do it the same way. So we're going to build a formula for data type rank, and the formula is exactly like Excel, equals rank, but we're going to use the parameters in our pivot table. I want to rank my data member between data member 1 to data member X, right? And then we're going to qualify those data members. We're going to say data member between product 1 and data member between product 9. The one thing we need to do here is we can't have the brackets. It's got to be one full statement. Let's validate. Save the rule. Let's move it down in our calc order. And now generate our rules. Now, just to test out our rank function, we're going to build out a random data set just to generate some random data to prove out our code. So just drop in here. Let's set the values on sales to randomly move between 100 and 200, and have cost of goods sold randomly move between 75 and 95. Save that. Load the data. Data's loaded. Now let's jump over to build views. Maybe run our default view to get a sense of whether we got data, which we did. And now let's set up a view that we can see the ranking by company. We can see the data and the rank. Maybe move sales out of the equation and have all the products. As you can see, here's a ranking of every product across every company. In this situation, we're going to show you how to do prior period. We have a model that has a data type, a product dimension, and a time dimension. 3 dimensions in this model, just to prove this out and show you how it works. So now we're going to put in some sample data, because this is what you would typically do in your Excel model, but you'd have to do it for every product. You'd have to say, oh, I want to pick up January for the first month of the year to date, but after that pick up prior year to date plus this month, and then carry that formula all the way through. And as you can see, the sum of the sales for all the months equals our year to date value. So let's create one rule here that helps us do this across all our products. So we take our month and we say, hey, we want the month plus we want a year to date value, but what we're going to do is we're going to put in some time intelligence. So we're going to grab the time parameter and pick -1 instead of 0, and that's going to pick up prior period. Validate. And now let's build out our rules. Formulas created. Let's jump over to build views. In this situation, what we're going to do is we're going to set up a view. We're going to use the product and the data type, so move that over. And instead of creating a random data set, let me just show you a different way to do this, and that is you can actually just enter the data into the form, carry that across. So we've now put data in for product 1 monthly. We're going to copy that. We can do this in real time, or we can do it in a batch way, which I'm about to. Write the whole form back and get the results. And here we are. We're looking at the results for the year to date. Notice in our year to date, though, the year value, it's actually summed up for the total. So let's create a rule for that, for year to date specifically. And we just want to say that this equals the year to date value and qualify that to be specifically the month of December. So we'll go to time and we'll grab December. We need to take the brackets out to make it one full qualified statement. And we're going to filter this by time for the year itself. So that way it's only going to happen on that particular value. Save it. Rerun the calcs. Formula is created. Now refresh the view, and now you can see year to date is the correct value. Let's extend on this time intelligence concept in Rumfox to solve problems for situations like beginning and ending inventory. So here we have as an Excel model beginning inventory equals prior month's ending inventory, so you can see how that works. At the end of the year, beginning inventory actually equals January's value, then the sum of activity subtracted equals the ending inventory for the year. How would that look inside Rumfox? Let's go to the rules and open this up and let you see how this works. The flow logic is such: ending inventory equals beginning inventory minus activity. Beginning inventory equals here with the time intelligence ending inventory for prior month. So you can see here. Beginning inventory for the end of the year, you can see that filtered such, is going to be January. And then the summing up of the months is only going to occur for activity. And let's run these formulas. Formulas created. So let's view our results. Let's go over to build views, maybe open up another spreadsheet, say build. We're going to see product 1 over time. We're going to put in $5,000. We're going to write that back to the database. So now that's our beginning balance with no activity. We can put activity in like we've done in the past, but let's create a little random data set. We're going to have activity for all the products to happen randomly between 100 and 200 bucks. We're going to send that back, replace the values, no. Remove the data set, no. Now when we run it, we refresh, and we can see our calculation working across every member in our pivot table structure. In fact, let's go back and build the views and lay out the products. Now we can see it going across all the products. Let's put beginning inventories in for the different products. 6,000 for product 2, 8,000 for product 3. Write that back, and now our results are in our model. Another powerful capability within Excel is its forecast feature. And I always like to show these features and how they work in Excel, and then how you can extend upon them by leveraging Rumfox. So you put in forecast, left bracket, you put in your X value, then your known Y's, comma, and then your known X's. As you can see, 220s a natural sequence to the other sales figures. I drag that out and then also drag it to the cost of sales, and you can see the same margin going across to validate our calc. So let's look at our Rumfox model. Here are the accounts with the period, margin, and sales and cost of goods. But let's look at the dimensions. You got accounts, time, years, product. Let's look at the other dimensions. Here's time, here's this year and next year, and here are the products. So that makes up our Rumfox pivot table. So let's take a look at our formulas. If you look at the sales formula, we have the same forecast routine as you wrote in Excel. The period of next year is our X, and then we're looking at this year from sales, January through December, for known X's and known Y's, and we're filtering on next year. And that's how the model can grow in the same way the forecast routine was growing in the Excel example that we showed you. We perform the same logic on cost of goods sold. Let's open up the formula so you can see it a little better. The X and the known Y's and the known X's. What's interesting here, if you notice, it says calc in store. We've checked that, and the reason we've done that is so now when it forecasts, it'll forecast it out, but then if you want to override those values, you can. So you can either have it calc all the time or have it calc in store for a one-time calc. So now let's go over to our build views, right? Set up a blank sheet. Let's set this up in the exact same framework as our Excel model so you can see how they compare. We're going to take the year out so you can see it extending across the months. And then you see this year, next year. We're going to put in our sequence here. And again, we could probably put this in a different way with a data set, but for right now, this is just an example. We load that in. And now we put in the same historical data that we had in our sample Excel model. Put 100, then $110, so it would grow incrementally by 10. Such. Take 50, we'll put 60 in here, do the same concept. And now write that all back to the database. And now we have our results. But notice cost of goods sold hasn't been calculated. So what we did is we put the data in, and for sales, it calculates every time. But for us, if we run the calcs now and refresh the data, we can now see it dynamically calculating for cost of goods sold. So what does this mean? Basically, let's kind of reassess. So let's make it a little bit smaller so you can see that on the whole screen. Sales is being driven, the forecast is being driven off the historical information. Therefore, if I change the historical values, maybe 200 and 300 here, and now refresh the data, it's going to dynamically reset the new forecast. Cost of goods sold, what we're doing here is to kind of show you the capability of seeding the forecast. So in essence, this way you could actually seed it and then say, you know something, I don't like those numbers, I'd like to override them. But it gives the user a chance to see what it would look like if it was forecasted forward, and then the ability to tweak the numbers afterwards.